All right, your learning target today is I can graph a rational function. So get that done. We're moving into one of my favorite sections to teach in Algebra 2. And this section, um, this section is really, really, really important for pre-calc and very important for calculus. You will be talking about rational functions and you'll be graphing these using derivatives and second derivatives. You'll be talking about things like concavity and points of inflection and where the graph is increasing and where the graph is decreasing. And it all starts today with the basics of what I'm going to teach you about it, okay? So, and that's why I really like teaching it because well, everything's connected to calculus, but there is a lot here. The first thing we need to know about a rational function is what is it? Okay, what is a rational function? And a rational function is any function where you have a polynomial in the numerator and a polynomial in the denominator. Now, there's going to be a lot about graphing this rational function. You think about where you guys started with graphing. You guys started probably in, I don't know, middle school, just graphing a point. Remember when you just got comfortable graphing a point, X and Y? And then you went on to graph a line. And then we went on to graph a quadratic, a parabola. Then we started graphing cubics. We started graphing quartics. We graphed the cubed root, the square root, the absolute value, and we just finished graphing exponential functions and logarithmic functions. And now we're on to rational functions, and we're going to graph them, we're going to simplify them, and we're going to solve them. Okay, so the first thing is this graph has a horizontal asymptote, and I want to talk about that horizontal asymptote. And there are 3 cases with the horizontal asymptote. And we're starting with it as the intro to talk about what a rational function is. But this will be the last step when we actually graph them. Now I'm going to give you all of the directions first. You might feel a little uncomfortable at first when I give you these directions. It's kind of like if you've ever been in the car with your mom and dad and Siri is on. And I've told this to some of you guys before, and your mom and dad are, or yourself if you can drive already, and you're like, I don't really know where I'm going. But you don't give up and like go back home. You just keep going, and eventually Siri normally gets you there. Granted, she's made a mistake once in a while, but she will get you there. So bear with me as we go through all of the steps first, and then we'll set it in action with an actual problem. So I want to talk about this horizontal asymptote, and there's 3 different cases that happen with the horizontal asymptote. And the first one let's talk about is case 1. Give me a second. I'm going to hide case 2. Okay. Our first case is 4x minus 1 over 2x squared minus 1. So you can see we have a polynomial function in the numerator, and we have a polynomial function in the denominator. And then I actually want to show you case 2, and I want to just talk about comparing them for a second. So my second case is I have 4x minus 1 over 2x minus 1. Now I want you to look at these right now, and I want you to say, what do you notice about these 2 polynomial functions? I'm sorry, these 2 rational functions. Granted, I don't have it as y is equal to, and I technically should, so forgive me. But I want you just to look at the numerator and the denominator, and I want you to compare case 1 to case 2 for me, please. What do you notice? You can raise your hand now if you notice something. Matthew, what do you notice? Yeah, case 1 has squared and case 2 doesn't. And do you remember what we call the highest exponent in a polynomial? Close. The leading coefficient is like what I used to call the line leader. It's the number that goes with the highest exponent. Someone else said it, I think. The degree, very good. Okay, so the different cases here, and here's, I lost my pen for a second. Case one is where you say, whoops. You compare the degree. What a nice class you guys are. Okay. The degree of the numerator is less than the degree of the denominator. If I just put DEN, do you know what I'm talking about? Okay. And then in case two, what would we say about the degrees of the numerator versus the degrees of the denominator? They're the same. Yeah, so we're going to write that down here in a second. So here we have the degree of the numerator is equal to the degree of the denominator. These are things you're going to have to analyze. There's a lot of analysis in these graphs. Now we're talking about the horizontal asymptote. We look at the degrees. Well, so what? What does that mean now? Okay. Well, what that means is if the degree of the numerator is less than the degree of the denominator, then your horizontal asymptote is y is equal to 0 every single time. That's the x-axis. Okay, that's the x-axis. Y is equal to 0 is your x-axis. And then we have the degree of the numerator, which is equal to the degree of the denominator. And what we do there is we take the leading coefficients and we write them as a ratio. Do you know what I mean by a ratio? What does that mean to you? A fraction. Yeah, we write them as a fraction. So what is the leading coefficient of my numerator? 4. What's the leading coefficient? Thank you for that enthusiasm. So as my leading coefficient here would be y is equal to 4 over 2, which is y is equal to 2. And there's my horizontal asymptote there. So we need to write a little note to ourselves for case 2, and there's not a lot of room, I apologize. Let's see if I get a little bit under here. If I say the function is a to the x plus b over c to the x plus d. It's times, thank you, Jack. A times x plus b, and then c times x plus d. What is my horizontal asymptote there? Y is equal to a over c. Very good. So that's kind of my rule there. When they're equal, you take the leading coefficient of the numerator and the leading coefficient of the denominator, you write them as a ratio and simplify that. Now there's one more case. That's case 3. What do you notice about case 3? How is it different than case 1 and case 2? Gunnar, what do you notice? Very, very good. The numerator is not a polynomial, okay? It's actually a constant, and that's okay. It's okay to have a constant in the numerator. That's a good observation. And I put that there for a reason, so you knew that was okay. And also, exactly what Gunnar said, there's that addition of 2 out here. So what do we do with this addition of 2? Anyone have any ideas? We're going to analyze this first and figure out, okay? Stuart, you want to add something? That's exactly right. It shifts +2. So we take whatever this horizontal asymptote is, and then we add 2 to it. So we analyze this. So this is either going to be y is equal to 0 or y is equal to a ratio. Whatever it is, we figure it out, and then we add 2 to it. Very, very good, Stuart. Okay, so what is the degree of this numerator? 0. Yeah, it's 0 because there's no exponent, right? You could write it as x to the 0 because x to the 0 is the same thing as what? 1. And 0 is less than the degree here of 1. And when your degree of your numerator is less than your degree of your denominator, it's always y is equal to 0. Oops, come on. And then we just have to add 2 to it. So my horizontal asymptote is that y is equal to 2. We're going to spend 3 days on this section. We're going to introduce a little bit more tomorrow, and then on Wednesday we'll have a work day over it. There are 5 pieces to graphing a rational function. It's not as easy as y is equal to mx plus b. Are we ready to move on? Okay. All right, here are the next pieces, and I'll go through them a step at a time. You're going to need to find the vertical asymptote. And how we find a vertical asymptote is we set the denominator equal to 0 and we solve. Now, if you think of a vertical asymptote, that's something that's on the x, it's like x is equal to something. And that makes sense because in the denominator, if you think about a fraction, I can't have 0 in the denominator. That doesn't work. So we have an asymptote there, and your lines won't cross it. You also will have to find the x-intercept and the y-intercept. The x-intercept is wherever what y is equal to 0. And to figure out whatever y is equal to 0, we need to think about our function and say, well, how is this going to be 0? Well, what makes a fraction equal to 0? The numerator, right? Okay, so we have to set the numerator equal to 0 and solve for x. The y-intercept, we just set x equal to 0 and we evaluate. And then you need to get points. And you're going to use a table and you're going to plot 1 and 2 points to the left and right of all vertical asymptotes. All vertical asymptotes for the other points. And we're going to practice it here in 1 second. I had a lot of examples. I think we'll only get through 2. You will have homework today, but I'll try to shorten it if we go a lot longer here. Tomorrow, all we're going to introduce is something called the slant asymptote. So hopefully we can get through a couple here. and then there won't be a lot of notes tomorrow. Are you okay if I move on? I'll wait, don't worry. It's okay. Thank you guys for being so nice and quiet while I'm taping. You guys are always usually nice and quiet anyways, but I appreciate it. Are we good? Okay. All right, your first example here. It's just y is equal to 2 over x. Y is equal to 2 over x. So our first thing that we have is, I know I started with the horizontal asymptote, but I said in hindsight, you're actually going to end with that, but that's the one that's the most tricky, so I really wanted to devote the most time to that one and then just boom, boom, boom through the other ones, because those ones aren't so bad. Okay, so I want to look at this and I would say, okay, well, what's the vertical asymptote? And what does it say in your notes? To find the vertical asymptote, we have to do what? Set the denominator equal to 0 and solve. So I like to call the vertical asymptote, I just put VA, so we don't always have to write it out. So we're going to say VA, we're going to set the denominator equal to 0 and solve. Well, my denominator is x, I set it equal to 0, do I need to solve? Yes or no? No, I do not need to solve. X is equal to 0, that's my vertical asymptote. The next thing I want you to find then is your x-intercept. What does it say in the directions for your x-intercept? Yeah, so the x-intercept, we would set 2 equal to 0. Well, why am I setting 2 equal to 0? Well, if you think about it, I'm actually setting y equal to 0, if you really think about it, right? Because the x-intercept is whatever makes this y 0. So if I have 0 is equal to 2 over x, does that work? Think about it. If I try to solve for x by cross multiplication, that gives me 2. Well, 0 times anything is 0. Does that work? No. So is there an x-intercept? No, there's no x-intercepts. And that happens. That means it will never cross the x-axis. The y-intercept. What does it say in your notes for the y-intercepts? Set x equal to 0 and evaluate. 2 divided by 0, does that work? No. 2 divided by 0 does not work. You plug that in your calculator, you're going to get an error. It's undefined, yeah. There's no y-intercepts. The horizontal asymptote. What is the degree of the new? And we can just call that HA. What's the degree of the numerator? 0, very good. And what's the degree of the denominator? 1. So we need to analyze that now. Is the degree, if the degree is less in the numerator is less than the degree of the denominator, what do we do? What is it equal to? Look at your notes. Yeah, y is equal to 0. So our horizontal asymptote is y is equal to 0. Yes, question. Yeah, how do I know the top exponent is 0? That's a good question, Brenna. You know the top exponent or the numerator's degree is 0 if there's no variable there. So if it's just a constant up there in the numerator, just a number, it's always 0. Okay, it's always 0. Does that answer your question? Okay, and then we need to get our other points. I suggest before you get your other points, you graph everything, okay? Let's graph everything that we know about this rational function right now. So I'm going to make a nice big graph. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I'm going to start with my vertical asymptote. And my vertical asymptote is at what? X is equal to 0. So I'm going to take a different color, and we'll see that here, and I'm going to draw a dotted line at X is equal to 0. And then I'm going to say, do I have an X-intercept? No. Do I have a Y-intercept? Nope. I have a horizontal asymptote at Y is equal to 0. And then what does it say in your steps for the other points? How do I get those other points? Yeah, I need 1 to 2 points to the left and 1 to 2 points to the right of all your vertical asymptotes. So I'm going to take X, Y. My vertical asymptote is at 0. So I'm going to plug in -1 and -2 and 1 and 2. So -2, -1, oh, not 0, sorry. 1 and 2. My function, as a reminder, is 2 over X, right? So I'm going to take 2 over -2. And what does that give us? -1, right? 2 over -1 gives us what? -2. 2 over 1 gives us 2. And 2 over 2 gives us 1. So -2, 1, 2, -1, point right here. -1, -2, 1, 2, and 2, 1. And what do we know about the asymptotes? They don't what? We talked about asymptotes with logarithms and exponential functions. They approach them. So what it's going to look like is this. Watch. It's a curve, and it's going to approach this vertical one here, but it will never cross it. And it will approach this horizontal one and never cross it. And then again, it's a curve, and it will approach the vertical one. It won't cross. And it will approach the horizontal one and never cross. And if you need to confirm that you have done it right, where do you go? You can go to decimals. Go to decimals. So this is the most basic rational function you will ever see. It's like the easiest one that you will ever see from here on out. So I want to do one more difficult one with you, and then I will give you your homework. Are we ready? All right. Okay, let's actually go a little bit more difficult than that. Let's do this one. Okay. So I have all the steps up there again. You don't need to rewrite those. Let's just practice doing it together. So we have y is equal to x plus 1 over x minus 4. All right. Step 1, vertical asymptote. What does it say to do? And solve for x. X minus 4 is equal to 0. What is x equal to? X is equal to 4. Do you have to show this x minus 4 is equal to 0? No. If you can see it, that's fine with me, okay? You don't have to show that work. But x minus 4 is your final answer there. The next step is your x-intercept. How do you find that again? Yes, and remember why we set the numerator equal to 0. Because we want this fraction to be 0, because we know the x-intercept makes y 0. That's important if it gets more difficult, because it will. Okay, but right now we just set that numerator equal to 0. X plus 1 is equal to 0, and what's x equal to? -1, and it's my x-intercept is equal to -1, or you write it as a point, -1 comma 0. I do not want to see x is equal to -1. Why do I not want to see x is equal to -1? Because that's a line. okay? Well, X can actually, we can have a couple vertical asymptotes. We'll see that tomorrow, but I don't want you to confuse that. And you need to know the difference there. So either one of these is fine for me. The Y-intercept, what is that? Try again. What are we going to do with our Y-intercept? Set X equal to 0. Do I have to show my work here, guys? No. What is 0 and 0? It's 1 over -4. So it's -1/4. So you either write it as -1/4 or it's when X is 0. 0, -1/4. My horizontal asymptote, my HA. Is that too bad once you get in the rhythm of it? They do get more difficult tomorrow. What is my leading coefficient? Oh, first, before we go, we need to analyze the degree. So what's the degree of the numerator? 1. What's the degree of the denominator? 1. They are equal. So we have to take a ratio of the leading coefficients. And what is that equal to? 1. Y is equal to 1. Okay. Y is equal to 1. And then what did I say to do before we get those other points? Yeah, graph everything first, okay? That's going to make your life easier tomorrow. Okay, so let's go to our vertical asymptote. Our vertical asymptote is at X is equal to 4. I'll do it in blue. 1, 2, 3, 4. There's X is equal to 4 and a vertical line right through it. Sometimes people get confused about when it's vertical, when it's horizontal. I like that strategy of just plotting a point on the x-axis because X is for slicing a line through it. I can't slice it this way. That doesn't make sense, okay? Our x-intercept is at -1. We know we have a point here, okay? Our y-intercept is at -1/4, right here, okay? Our horizontal asymptote is at what? At what? Y is equal to 1, yeah. Plot a point, Y is 1 is right here, and then a horizontal line through it. Now we're gonna make a table. 2 to the left, 2 to the right. Well, we're at 4, so we want 5 and 6, right? And then we also want 2 and 3. We're going to plug those in. So what's our function again? Let's rewrite it so we can see it. X plus 1 over X minus 4. So Y is equal to X plus 1 over X minus 4. Is that right, guys? So if I plug 5 in, 5 plus 1 is 6. 5 minus 4 is 1. So 6 over 1, when I plug 5 in, is what? 6, yeah. 6 plus 1 is 7. 6 minus 4 is 2. So 7 over 2 gives me what? And we can use decimals. 3.5, 3.5. 2. 2 plus 1 is 3. 2 minus 4 is -2. So what is that? Negative what? 2 plus 1 is 3. Oh, -1.5. Is that what you said? Okay, sorry. I thought you said something different. And then 3 plus 1 is 4. And 3 minus 4 is -1. So what do we get when X is 3? -4. Okay, so let's plot these points. 5. We're at 6. So 1, 2, 3, 4, 5, 6 up here. 6, we're at 3.5. 1, 2, 3.5. Okay. 2, we're at -1.5. So about right here. 3, we're at -4. So right here. And now we know we can check decimals if we need to, but it's going to come up and it's going to kind of hover over this line right here and then come down and hover over that line. Down and hover. Over and hover. just like that. Do we have any questions? Okay, I have one thing that you may run into that I just want to prevent you from doing. I don't want to go through, and this is my bad. I don't think you'll run into it. In fact, I don't think I've ever run in, I've maybe run into it in calculus, but I want to just make sure that you have this down. And I'm gonna, now that it's 30 minutes, I'm gonna pause it. I don't need to get this on video. It's a long video, so.